our chapter number 4, mathematical induction. Example number first, page number 212. Example 1, let Pn be the statement. Pn is such that 10n plus 3 is prime if n is not divisible by 3. Is this statement true? Here we are given Pn 10n plus 3 is a prime number. Value of function Pn is a prime if n is not divisible by 3. We want to check this statement true or not true for all natural number or only natural numbers. Is this statement is true for all natural numbers? Take any number which is divisible by 3. Any natural number which is not divisible by 3 as 2. 10 into 2 plus 3, 20 plus 3, 23. 23 is a prime number or not a prime number? Prime. What is prime number?
Exist only on
their
table.
Is divisible which has only one factor,
which exists only on their table.
Table. So 23 is a prime number. If we take any value of n which is not divisible by 3, then Pn is 23, which is a prime number. Take any other number, for example 4, which is not divisible by 3. 40 plus 3, 43. It is also a
Prime number.
If we continue this process, our question will be very lengthy. So we will give only one example which make this statement false. Okay. Take n is equal to 13. We do not need to solve all these steps. In this question, we give only one example which will show given statement is false. Take n is equal to 14, which is not divisible by 3. Therefore, value of Pn of P14 is equal to 10 into 14 plus 3. 140 plus 3.
143.
143. Make factors of 143. 11 1 11.
3. 13.
13 1 13. So 143 has two factors, which is not a prime number. Which is not a prime number. but n is divisible by 3. Therefore, given statement is not true. Therefore, given statement is not true. Now, example number 2. For mathematical induction, prove that 1 plus 2 plus 3 plus so on plus n is equal to n into n plus 1 over 2. In all these questions, we will take value of n as 1, then take value n is equal to k, then prove this result for n is equal to k plus 1. Only 3 steps. All questions we will follow only 3 steps. We have to prove that one plus 2 plus 3 so on plus n is equal to n into n plus 1 over 2. By mathematical induction, we have to prove this result. Always our first step is for n is equal to 1. If n is 1, then what is left hand side?
1.
1. First term is 1, left hand side is 1. If we check right hand side is equal to 1
Left
into
hand.
1 plus 1 over 2. 2 over 2 is equal to
1.
Therefore, left hand side is equal to right
hand side.
Left hand side is equal to right hand side. Result 1 is 2 for n is equal to therefore 2 for n is equal to 1. Now we will suppose result is also true for n is equal to k. Assume the result is also true for n is equal to k. If result is true for n is equal to k, then we can put n as k. 1 plus 2 plus 3 plus k is equal to k into k plus 1 over 2. Now we have to prove that result is also true for n is equal to k plus 1 with this, with help of this step. For this, always we will add, check last number. What is last number? K. This number will, this last term will tell us what we will add both sides. If this is k, we have to suppose n is equal to k plus 1. So we put in place of k, k plus 1. Or we will add k plus 1 both sides. Adding k plus 1. Last term will tell us what we will add in both sides. Adding k plus 1 to both sides. Sides of 2. And we get 1 plus 2 plus 3 plus k plus k plus 1. K plus 1 over 2 k plus 1. Now what we have to prove to right hand side equal to left hand side. If we put n plus 1 over 2. We put k plus 1 in place of n. K plus 1, k plus 1 plus 1, k plus 2
2.
over 2. This is our answer. Solve this. Over 1, 2 is LCM, or 2, 1, 2. 1 multiply by cross multiply k into k plus 1 plus 2 into k plus 1. K square
plus k
we can take k plus 1 as common, k plus 2 over 2, or we can write k plus 1, k plus 1 plus 1 over 2. Okay, put a bar here. This is also a bracket. Which by comparison the result 1 show that z is 2, 4 and is equal to k plus 1. Therefore, result 1 is also 2, 4 and is equal to
k plus
k plus 1. Also, result is true. Also, 2, 4 and is equal to 1. Therefore, by method of induction, therefore, by method of induction, result 1 is true. One is true for R and belongs to n mean natural numbers. Okay, in all question we will follow these 3 steps. Take screenshot.
Done.
Take again.
Done, sir.
Example number 3. Use the principle of mathematical induction to prove that 1q plus 2q plus 3q plus so on plus n cube is equal to n square into n plus 1 whole square over 4. For R, n belongs to n. Question: we have to prove that 1q plus 2q plus 3q so on n cube is equal to n square n plus 1 square over 4. Now for again same steps. For n is equal to 1. Left hand side 1 3 is equal to 1, and right hand side 1 square 1 plus 1 square over 4. 2 square 4 over 4 is equal to 1. left hand side is equal to right hand side. Therefore, result 1 is 2 for n is equal to
4 and is equal to 1.
1. Assume that result 1 is 2 for n is equal to k. Assume that result 1 is 2 for n is equal to k. Therefore, 1q plus 2q plus 3q plus
and
kq
k
is equal to, put k in place of n.
is
K square k
k
plus
plus 1
K
one
square
square
over
over
4.
over 4.
now what we will add to both sides? Adding what we will add to both sides?
K plus 1.
Only k plus 1. What is our last term?
K
K
cube.
cube
K cube. When we will add k plus 1 cube,
Cube.
adding k plus 1 to both sides of equation of 2. Okay, this last term will tell us what we will add to both sides. Therefore, 1 cube, 2 cube
plus 3
cube
cube
plus
k cube
K cube
k cube k plus
plus K plus 1 cube.
cube. Now k square
k square k
K plus 1 whole square
1 square over
over 4
4
plus K plus 1 cube.
plus 1 cube. And what will our result here? Put k plus 1 in place of n. K plus 1 square, k plus 1 plus 1 whole square over 4.
4.
This should be our result of right hand side. Take 4 as LCM. 1 multiplied by numerator
K
a
square
square into
k
a plus
K plus 1 square.
then 4 multiplied by k
4 K
plus 1.
plus 1 cube.
And what is common in denominator? What is common in denominator? K plus 1 square. And we are left with k square
K square
plus 4
1
over
4
k plus 1.
4 K plus
1 over 4. Check what we find. K plus 1 square. Okay, so we will not touch this term, and over 4 is also exist. Now we have to prove k plus 2 whole square or k plus 1 plus 1. K plus 1 square into k square plus
Plus 4
4K
4k
plus
plus 4 over
4.
k plus 1 square.
square
We can apply splitting the middle term formula k
K
square
plus 4 whole
k square
2k
plus
2k
2k plus 2k plus 4
plus 4 over
4
4 k plus 1 square. K is common.
K
Plus 2
plus 2.
and plus 2 is common. K
K
plus
plus
3
2.
plus 2.
over
4.
4.
4. Now k plus 1 square. K plus
K
2
plus 2. K plus 2.
is 2 over
4.
4.
k
K
plus
plus 1 square.
square.
K plus 2
2
square.
square.
K plus 2 whole square
Over 4.
4. Or we can write k plus 1 square. K plus 1
Plus 1 plus
plus
1 square.
square over
4.
4.
before result is also true for
K plus 1.
k plus 1.
1.
Therefore, result one is Q4 and is equal to
K plus
1. Also, these are 2-3 steps that we will write at the end, same steps. Also, the result is 2-4 and is equal to 1. Therefore, by mathematical induction, method of induction, the mathematical induction, method of induction result one is
true.
2-4 all
And
n belongs
all
to
n belongs to natural number.
natural number. Now question number example number 4. Use the principle of mathematical induction to get 1 over 2 plus 1 over 4 plus 1 over 8 plus so on plus 1 over 2 power n is equal to 1 minus 1 over 2 power n. We have to prove that 1 over 2 plus 1 over 4
Plus
plus
1
1
over
over
6.
8 take a screenshot. Take screenshot.
Done,
Done.
sir.
1, 2, 3 number example. Take again. Hello.
Done.
Done, sir.
Example number 4. 1 over 2 plus 1 over 4 plus 1 over 8 plus so on plus 1 over 2 power n is equal to 1 minus 1 over 2 power n.
N.
For n is equal to 1, left hand side is
1 by 2.
1 by 2
2.
and right hand side 1 minus
1
1
minus
2
1 by
power
2
1
multiply
1
1.
minus 1 by 2 1 minus half 1 by 2.
2.
Therefore, left hand side is equal to right hand side. Therefore, result 1 is 2 for n is equal to 1. Assume that result 1 is 2 for
2 for n is n.
n is equal to
Okay.
Okay.
therefore 1 over 2 plus 1 over 4 plus 1 over 8
8.
plus 1 over 2 power k 1 minus 1 over
2k.
2 power k.
K.
Now what we will add in both sides?
K plus 1.
1 by 2.
1 by 2. 1 by k plus 1.
Repeat again. Repeat again last what we will add.
1 by 2
2k plus
k plus
2k k plus 1.
2k k plus 1.
1 by 2 k plus 1.
Adding both sides of 2. Adding 1 over 2 power k plus
K plus
1
K
1.
plus 1.
to both sides of 2. Therefore 1 over 2 plus 1 over 4 plus 1 over 8
8.
plus 1 over 2 power k plus 1 over 2 power
2k plus 1.
is equal to 1 minus 1 over 2 power k plus 1
1
over
by 2
2 power k
plus
plus
1.
1. One minus 1. What is common in denominator?
2k.
2 power k
K.
or 1 over 2 power k we can take common 1 plus 1 over 2, right? 1 over 2k plus 1 over 2k 1 into 2 power 1. When there is multiply between two numbers, then powers are added.
And
1 minus 1 over 2 power k, 2 is LCM, 2 plus 1, 3 over 2, 1 minus
1 over
3
2k.
over 2 power k plus
K.
1.
1.
What do we have to prove? 1 minus 1 over 2 k
K
power
K,
k plus 1.
1.
And there is one mistake. We take common minus as common, so there we will write minus because minus is common. Signs are changed. 2 minus 1. 2 minus 1.
1.
1. Okay. Therefore, result 1 is 2, 4, n is equal to
k plus 1.
plus 1. Also, result 1 is 2, 4, n is equal to 1. Therefore, result 1 is by mathematical induction, the method of induction. To 4, all n belongs to.
Belongs to natural number.
Now, example number 5. Take screenshot.
Done, sir.
Example number 5. In this question, we have to prove that that 1.2 plus 2.3 plus 3.4 plus 1 multiplied by 2 plus 2 multiplied by 3 plus 3 multiplied by 4 plus so on plus n multiplied by n plus 1 is equal to 1 over 3 into n plus 1 into n plus 2. We have to prove this in this question. Now for n is equal to 1, left hand side is
2
1 into 2, 2. And right hand side
by 3.
1 over 3 into 1, 1 plus 1, 1 plus
1 plus 2.
1 over 3, 2 into 3. 3 divided by 3, 2.
Is equal to 2.
Therefore, left hand side is equal to
Equals to right hand side.
right hand side. Therefore, result 1 is true for n is equal to 1. Therefore, result 1 is true for n is equal to 1. Now assume that result 1 is true for n is equal to k. Assume that result 1 is true for n is equal to
k.
k. Therefore, 1 into 2 plus 2 into 3 plus 3 into 4 plus k into k plus 1 is equal to 1 over 3 into k,
k plus
k
1
plus 1, k plus 2.
plus 2.
Now, what we will add in both sides of 2?
K plus 1. K plus 1.
K plus 1 only.
Plus 1 k plus.
What we will add both sides?
K plus 1 k plus 2.
K plus 1, k plus 2.
2.
Replace k by k plus 1. K into k into k plus 1. If we put k plus 1 in place of k, then k plus 1 plus 1 2.
plus 2.
K plus 1. K plus ਇਹ ਵਿੱਚ ਆਵਾਜ਼ਾਂ ਰਿਕਾਰਡ ਹੋਣੀਆਂ ਪਿੱਛੋਂ ਹੈਲੋ
हाँ जी
ਇਹ ਰਿਕਾਰਡਿੰਗ ਹੋ ਰਹੀ ਜਿਹੜੀ ਪਿੱਛੋਂ ਆਵਾਜ਼ਾਂ ਆ ਰਹੀਆਂ ਵਿੱਚ ਹੀ ਰਿਕਾਰਡ ਹੋਣੀਆਂ ਸਾਰੀਆਂ
Mute ਕਰ ਦਿੰਨੇ
ਤੇ ਤੁਸੀਂ ਬੋਲੋਗੇ ਕਿਦਾਂ now adding k plus 1 k plus 2 to both sides of 2 1 into 2 plus 2 into 3 plus 3 into 4 plus k into k plus 1 plus k plus 1 into k plus 2 is equal to
1 by 3 k plus 1 k
Okay.
plus 2
k plus 1
k plus 2
plus 2
k plus 2
k plus 2 okay take common k plus 1 and k plus 2 k over 3 plus 1 k plus 1 k plus 2 3 as LCM take 3 as LCM k plus 3 what do we have to prove in this example 1 by 3 k plus
K
1
1
k plus 1 plus 1 2 k
2
plus 1 plus 2 k plus
3
3
3 k plus 1 k plus 2 k plus 3 okay 1 by 3 k plus 1 k plus 1 plus 1 k plus 1
plus 1 plus 2
plus 2 okay therefore result is true for therefore result 1 is 2 4 n is equal to
k plus 1
k plus 1 also result is true n is equal to 1 therefore by method of induction result 1 is 2 4
and
r
belongs to
n belongs to
belongs to natural number
n. This chapter we have 12 example and only 35 questions. Okay. Take screenshot. Take
answer
example number 6. Use principle of mathematical induction to prove that solution we have to prove that 1 over 1 multiplied by 2 multiplied by 3 plus 1 over 2 multiplied by 3 multiplied by 4 plus 1 over 3 multiplied by 4 multiplied by 5 plus so on 1 over n multiplied by n plus 1 n plus 2 is equal to n into n plus 3 n into n plus 3 over 4 into n plus 1 n plus 2. Now for n is equal to 1, left hand side, first term 1 into 2 into 3, 1 over 6,
6.
and right hand side 1 into 1 plus 3, 4 into 1 plus 1, 2,
1
1
plus 2.
plus 2, 3, 4 over 4 into 6, 4 divided by 4, 1 over
6.
So result is 2, 4.
Is
Therefore,
1.
result 1 is 2. Yes. 2, 4, n is equal to 1. Assume that result 1 is 2, 4, n is equal to k. Assume that result 1 is 2, 4, n is equal to
K.
k. Therefore, 1 over 1 into 2 into 3 plus 1 over 2 into 3 into 4, so on. 1 over k, k plus 1, k plus
K plus
2
2. K plus
is equal to k plus,
K.
sorry, k plus 1, k plus 2, k
K plus 3.
k plus 3 over
4.
4.
4 into
K
k plus 1.
plus 1. K plus 2.
Now what we will add to both sides?
K plus 1. K plus 2. K plus 3.
Yes. Adding 1 over k plus
K plus 1.
1, k
K
plus
plus 2.
2,
K plus 3.
3, both sides of second. Now this will become 1 over 1 into 2 into 3 plus 1 into 2 into 3 into 4 plus 1 over k into k plus 1 into
K plus 2.
2
K plus 3.
plus 1 over k plus 1,
K plus 2.
k plus 2,
K plus 3.
3 is equal to k into k plus 1,
K plus 2.
k plus 2,
Plus
1 over k plus
K plus
1,
1,
K plus
K plus
2,
2,
K
K
plus
plus 3.
k plus. Now take common from denominator. What terms are common?
K plus
1
1,
over
K
k
plus 2.
plus 1 and
K plus 2,
k plus
2.
multiply. K into
K plus 3,
k plus 3 over
4
4 plus
plus
1 over
1 over K
K
plus
plus
3.
3.
k plus 3. And what should be our result is k plus 1 into k plus 1 plus 3 4 over 4 into k plus 2 k plus 3. Okay. And what we gain 100 k plus 1 k plus 3 and 4 also we need. Take 1 over 4 also common. 1 over 1 over 4 k plus
1 K plus 2.
2 and k into k plus 3
3
plus
plus 1 by K plus
1 by K plus 3.
we take 4 as common.
4
4 over k plus
K plus 3.
3. When we will divide 1 over 4 by this term, then 4 divided by 4. One over 4 into k plus 1,
K plus
k
2.
plus 2. What we need more? K plus 1 and k plus 4 in numerator. Denominator is complete. K plus 1, k plus 3. Take k plus 3 also common. K plus 2. What we had common here? K plus 1 and k plus 2. Take k plus 3 as LCM. Multiply k plus 3.
K
K
plus
into k
plus
plus 3 square plus
4.
4. Will become more difficult.
गिनती लगा रहे हो आज उनको गिनती लिखा रहे हैं इतनी ठंडी हवा है
K plus 1, k plus 4, k plus 2, k plus 3. K plus 3 over k plus 1, k plus 2. K plus 1, k plus 2, k plus 3. Solve is rough work. You can solve. k into k plus k square plus 6k plus 9 plus 4 over k plus 3. Or we don't need k plus 3. If we multiply, then it will become cubic. Multiply k cube
Cube plus
6k
6k
square
square plus
9k plus 4.
4.
Now arrange these terms in such a way that we need any common bracket. K cube
K square plus 6.
made perfect square with these terms. K cube k plus 1, k plus 2, k plus 3. Now solve the result. This should be k into k square 4k, k into
plus
k
4
square 4k, k
plus 4.
k square plus 5k plus 1. Not match the result. We do any mistake in any step. K into k plus 3 over 4, k plus 2, k plus 1, k plus 2, k plus 3. So took a 4. To square, b square, then plus 2 into 2, 2 took a 4, and 3 can 9, 2 took a 4, 6 4 24. 2ab. B square or k square plus 5k square
Look at the good. Lady, just look.
k. What we need k plus 1 and k plus 4. K plus 1 and k plus 4.
3k plus 3k.
K plus 1, k plus 4.
Also,
We need k plus 4 and k plus 1 square, because in denominator we have 1 k plus 1 extra. K plus 4, how we will take k plus 4?
3k
K
plus
plus
3.
4. What is
3k plus
extra?
3k.
K plus 4 plus 8k plus k square plus 6k square. K cube. K cube 6k square 8k. If this is perfect square number. 8 1 का 8, 4 2 का 60 का. Okay. You can take k as common. K square
Yeah.
plus 6k plus 8 plus k plus 4. Now k into k square plus 4k into 2k plus
Let's
8,
say
8.
k plus 4,
4.
k into k common, k plus
K plus 4.
4 plus 2 as common,
k plus 4.
k plus 4 plus k plus 4, k into k plus 4 into k plus 2 plus k plus 4. Now what is common here? K plus 4, k plus 4 common, and we left with k into
K
k
plus
plus 2 plus
1.
1.
1.
Now k plus 1, k square plus 2k
2k plus
plus 1, k plus 4, k plus 1 whole square. Okay. We will write all these solution after this. Okay. Now we are left with 1 over 4 into k plus 1,
1. K plus
k
2.
plus 2, and
K plus 3.
multiply by k plus 3 into k plus 1 square multiply by k plus
Plus 3.
4. That k plus 1 is divided by k plus 1. Now we have k plus 4 over 4 into k plus 2 k plus 3.
3.
K plus 1 k plus 4 over, check results answer. Our answer is k plus 1, k plus 1, k plus 1, 4, k plus 2 and k plus 3. We can write it as k plus 1 plus 3, k plus 1 over 4 into k plus 1
Plus
plus
1
1
plus 1.
plus
3 plus 1.
Plus 2.
answer result is 2, 4 and is equal to k plus 1.
1.
If some we have any problem to show the result, we can take help of our result. Okay.
Yes.
Yes, sir.
Therefore, result is 2, 4 and is equal to
1.
k plus 1. Also, result 1 is 2, 4 and is equal to 1, and therefore by mathematical induction, a method of induction, result 1 is
2, 4. And
1 is 2, 4 and is equal.
n is equal to n belongs to
Natural number.
n. Okay. Now 6 examples are left. We will do it then tomorrow.